Let us now try to consider some sample problems. A vertical rectangular gate 1.5 meter wide and 3 meters high is submerged in a water with its top edge 2 meter below the water surface. Find the total pressure acting on one side of the gate and its location from the bottom. So the first thing that you have to do when solving up a problem is to draw the figure and to label it properly. But before we do that, I want to show you a sample picture of an actual rectangular gate for your awareness. So this is an example of vertical gates, the one that is being pointed by the yellow arrow. So whenever it is desired to release water out from a dam, the vertical gate will be pulled up and the water will come out flowing. If they want to impound, the gate is closed. If there is an ample supply of water and they want to release it, say for irrigation, they will lift up the vertical gate. This is just one of the examples of a vertical gate. So going back to our discussion, we have a vertical rectangular gate, 1.5 meter wide and then 3 meters high and is submerged in water with its top edge 2 meter below the surface of water. So if this is the surface of water, the top edge is 2 meters below the surface of the water. So we are to find the pressure acting on one side of the gate and its location from the bottom. So since our plane is rectangular, the center of gravity is acting on its neutral axis. So working equation for force, that is simply the unit weight of water multiplied by the bars of H multiplied by the area. We know the value of the unit weight of water. This is constant. And then bars of H, from our previous discussion, we have said that bars of H is the vertical distance reference from the center of gravity up to the point of water surface. So this is now your bars of H. And then the area, since the dimension of the gate is given, we can easily calculate the area of the plane. Bars of H is simply 2 meters plus 1.5, so that is 3 meters. We substitute the unit weight of water is 9.81 kilonewton per cubic meter times the value of bars of H, which is 3.5 meters, and then the area. So your meter and your meter square will cancel out with the cubic meter. We are left with the kilonewton as our unit. Therefore, the force is 154.508 kilonewton. So next is, what is the location of the total pressure from the bottom? We always know that the force is acting on the center of pressure. So we also know that the distance between the center of gravity and the center of pressure is E, or eccentricity. Since we know that from the center of gravity up to the edge of the rectangle is 1.5, and once we calculate the value of E, we can simply subtract the values from 3 meters for us to be able to get the value of Y. So first, we have to solve for the value of E, or eccentricity. That is the moment of inertia divided by the area multiplied by bars of Y. Since our figure or our plane is rectangular, the moment of inertia for rectangle is, that is simply 1 all over 12 base times height raised to 3. This is our base, this is our height. So substituting, E is equal to 1 all over 12. The base of the gate is 1.5. The height is 3 meters. And then the area is 1.5 by 3. And then the bars of Y. So from our previous discussion, we said that the bars of Y is the inclined distance from the center of gravity up to a certain point. But since our example is not inclined, but it is vertical, therefore, bars of H, our bars of H is also equal with bars of Y. So we can simply use the value of bars of H. So we substitute Our E now is 0.214 meters. So from there, Y is the total height of the rectangular gate minus 1.5 minus the value of E, that is 1.286 meters from the bottom of the gate. So that is now our answer.